Hello everyone, today I'm going to be interviewing the team of NTNU, which is the award winner of the 9-kilometer solid propulsion rocket for the EuroC challenge. I'm happy you're here. So what's your story and how do you meet each other?
I applied to Propulse NTNU in 2020, became the system leader of outer structure, which is within the mechanical group. Well, I just loved working in Propulse NTNU, so I decided to apply for the project manager role. That basically means the leader of Propulse NTNU, and that is what I am today. And I study physics, bachelor of physics, here at NTNU in Trondheim.
My name is Simon, and for this year's project, I'm the mechanical lead. I too joined Propulse the fall of 2020 as inner structure system engineer, also a part of the mechanical group for the main project that year, Project Stetind, that flew in Portugal. A big space geek. I love watching rocket launches, and I love to follow what's happening at Boca Chica in Texas, for instance, and I love working on rockets in my spare time here in Trondheim. And I study material science and engineering. And I met Thea in 2020 when we worked on the same project on the mechanical group, Project Stetind.
I think we've been looking at some of your videos on YouTube and the last with Dare. And I think it's really impressive what you do. And are you going in 6th grade?
Yes, I'm going in 6th grade.
That's cool.
Thanks.
Yeah, that's a good start. If you start, or if you continue in this pace, I think you might find yourself in a student rocketry team in a few years.
Yeah, just in a few years.
Well, currently I'm working on building us a rocketry team.
Right. Okay. And what is barneskolen? What is that called? The school when you go from 1st to 7th grade, whatever the name of that is.
Yes, so 6th, 7th, and 8th is middle school.
Okay, middle school. That's good, So then you will have a rocketry team for middle school students.
I think it will be separate from the school, because then there's the problem if they're only 3 years. Well, then everybody who knows how to build rockets well will go away.
Yeah, that's right. Well, if you guys do that, let us know. Then we'll visit you in Italy and just watch you guys.
How's your university? What you learn? What language do you do your lessons like?
Yeah, we can just start with I guess that's a bit biased to say, but we have great universities here in Norway, and in particular NTNU, mostly because NTNU is quite large university, so you have all kinds of study programs, and there is many of them. You can take in English, that is an option, or the mandatory language to use. And also what makes NTNU here in Trondheim, that stands for Norwegian University of Science and Technology, is all the study programs that in particular here in Propulse NTNU, we can take advantage of that, have interdisciplinary discussions and work together with people from completely different study programs and learn from each other. So there's a large student environment for technical organizations such as Propulse NTNU.
Trondheim is known to have a great student culture. We have, as Thea mentioned, a lot of technical organizations such as ourselves, where students work on their free time completely voluntarily. But it's not only technology-based organizations, it's some cultural stuff going on, and there's an entire building in Trondheim called Samfundet, or the community, which is run entirely by students, for students, where almost every day there are some concerts or something going on. So there's always an offer to do something as a student here in Trondheim, which is why it's the most popular university, among other reasons, in Norway.
How do other students think of what you do?
Well, that's a good question. I hope that other students, and I believe that other students that is not a part of Propulse NTNU, looks and thinks this is crazy. This is pretty impressive. Well, I can tell when I first got to NTNU, I was hoping I could have some subjects within the astro field, within space. But that was just a hope that I had. So when I first realized that there is a student organization that makes rockets and you can participate in international competitions where you launch them, that was pretty insane to think about, because that's not something you hear at school before that. So I was very impressed of the work that they were doing in Propulse, and I hope that there are more of the students that see what kind of possibility this is, that you can actually make a true rocket and see it launch. That's amazing.
And I would like to add that most of the people I talk to, when they ask me what I'm doing with my life, and I answer, I build rockets, and they are quite shocked, like, what do you mean you build rockets? It's how? So just the word rocketry has kind of a high association to it, and furthermore, when we actually show them the videos of our rockets when they launch, when they reach speeds past 2,000 kilometers per hour, it's even more shocking. But also the downside of this, I think many people are underestimating their own abilities to the extent that, okay, that's a cool project, but I don't think I have it in me to join. And that's, I didn't think I necessarily had it in me when I joined, because I have never built a rocket before. I don't know how to build a rocket, but after you've been a member, you at least have gotten the opportunity to figure out how you build a rocket, and then it's more trivial to you than the word rocketry means another thing after you've worked on it for some time. But I won't say it's easy by no means, but you kind of know like the limitations, the possibilities. You're not just blinded by your pre-assumptions about the word rocketry.
Do you have any advice for a high school student that wants to be prepared to join your university and your team?
First thing, the most important thing is just go for it. Don't be afraid. The worst thing that can happen is that you try and okay, it's not exactly as you planned, but then it will develop and then you will learn and then it will be the best experience you've had if you just have the guts to do it. And that is very important for those who applied to Propulse. I think they all had some guts. They just had to, I will apply, and if I get a no, then all right. And then they come in and they have the time of their life. And I think that will be the same for the high school students that wants to join either the university, our team, or if it's a job. So yeah, just try. And if you get no the first time, don't stop trying.
Yeah. And when you're at high school and trying to decide on what you're going to do next, my tip is to think about what do you know from before, what are you interested in, as in what am I the best at in my life now. For me, it was I'm interested in rocketry and science. Therefore, it's natural for me to go in that direction because then it will be more like intuitive for me because I'm already in that mindset. So that was a main or a large contributor as to the direction I chose, which in my case was material science and engineering. Figure out that that's an important field of study when developing new technology. And I wanted to be a part of that. So that's why I went that way.
How many are you? And if you plan to go to space, how do you want to get to space?
2019, I think that is when we started. Or in 2018, we were around 20 people. Now in 2022, we are around 60 with plus mentors. Then we're more 70, 80 people. So we are growing. And well, our roadmap towards space, that is quite large roadmap. But as of now, we are participating with a COTS solid engine, while we will continue then with the hybrid and then liquid. And then our long-term goal is to reach the carbon line. So our roadmap is, it is hitting space at some time.
Of course it is.
Of course.
What are your goals and strengths?
I would say there is a lot of, we can just start with the strengths, a lot of strengths here in Propulse. But for me, the one I see the most clear is the motivation within the team, the engagement, that people come here and work for 12 hours with a project, and we don't do it alone. You do it with your team. If it is for the technical report, if it is for integration test, yeah, you work hard for a common goal, and that is yeah, the motivation within the team is a good strength we have in Propulse.
Another thing that we have touched into already is the fact that there are students from different fields of studies, different faculties from the university. So you're not like the one and the same person. It's different people, different backgrounds, different knowledge base from their studies, and that's what makes the team fun to work with, and new experiences within the team due to different members and so on. So it's always fun coming here to the office, people working, yeah, a lot of fun stuff going on inside this room. So it's a good team spirit. That's one of our great strengths.
Yeah, and well, for our goals, as I mentioned, a long-term goal is to reach the carbon line. For this year, Team 2022, our goal is to, well, there are a lot of them, but participate in Spaceport America Cup 2022 with our rocket Birkeland, and perform well there. We want to repeat our success from last year, and that is yeah, a more short-term goal, but reaching the carbon line is what we will work throughout maybe the next 5-10 years. Yeah.
Which skills can someone learn by joining your team? And does somebody need to know some stuff to join the team?
When we look for new members, we don't really focus on their knowledge base from beforehand. This is, of course, important for some of the positions that we want to hire people for, but in general, it's more of the motivation, the excitement of learning new things that we look for in new members. And as a member in Propulse, you will be able to do a lot of different things, but you will at least figure out how the route from idea to concept to design to finished product, that route you will get to know quite well. That's for me at least, was a great experience to start with an idea inside my head and try to get it down on the paper, then get a 3D model of it, 3D print it to get a feel of how it looks, and figure out how you're going to produce this thing and test it. Then finally you have it on the launch rail, and you're looking at it going straight up in the air, and you're able to inspect it afterwards and see, wow, the idea that didn't exist before it came into my head actually did a good job here. That's kind of the root thing that you will get to know. This is something you don't really get through school. So this is an important thing, in my opinion. And also, depending on what team you're in, depending on what product you are designing or which subsystem you are designing, the amount of manual skills and tasks are kind of depending, but for the guys on the mechanical team, at least, you will get to do some production. A lot of it is automated, as in CNC based, but there are some manual production on a lathe, for instance, and we use a lot of different tools for testing, so you are able to use your handy characteristics as a member of the mechanical team, and also some of the research and development teams that we have. So you get to become a better engineer. You get to see what it is like to actually work on something that doesn't have you don't know the answer before you have tested it out. That's a big difference from our project and the way you're taught in school.
How can someone join your team, and how do you recruit people?
Well, the way you can join our team, well, first off, you have to be a student, or as of now, you have to be a student here at NTNU. And then for joining, you can apply in our application that we have online. And we have, well, there are different phases for the recruitment, but the main recruitment happens in August, or in August, September. And yeah, the ideal candidate for Propulse is the ones that are motivated, that shows a passion for space, that wants to put in the hours needed to make a rocket, and that and working with the team is something they look forward to, and they want to, and eager to learn and willing to learn. That is the most important thing we have in mind when we recruit. And yeah, in the recruit period, we have all sorts of, we have stands at the campus, and we also have a lot of things going on social media. So yeah, as of now, you have to be a student at NTNU, but yeah, we'll see. Maybe that will change in the future.
Could someone join an online design review?
Yeah,
absolutely.
Yeah, we have 3, or as of now, we have 3 design reviews: the concept review, the preliminary design review, and the critical design review. They sort of ends different phases, and here we invite both the members, mentors, and also sponsors and collaboration partners, but it's open for everyone that wants to have a look or come with feedback, and we really appreciate that. So yeah, definitely everyone that is interested should join and contribute online at the design review.
By sending an email to us,
Yeah.
Propulse email, I want to attend the review. You'll get a link when that time comes.
How are you organized?
Propulse is divided in different groups. Well, at the top, you have the board with the different leaders. You can call it leader group. Then you have in the main project, they are the ones that competes in the international competition. That is the mechanical, which Simon is the leader for now. Then you have the avionics. And then we also have R&D, or research and development groups, which is now hybrid, that develops our hybrid engine. And then you have Penumbra, that develops our trajectory simulator. And then you also have a business and marketing group, that is for the entire organization, and as the name implies, it's the business and marketing. And within those groups, you have different systems. So in mechanical, you have the outer structure, inner structure, and recovery. And there you have the system leaders, such as that's what I was last year.
How do you manage your team, and do you have remote members in your team?
We do not have any remote members in our team, because when we are working together, it's important to be able to look each other in the eye and share opinions and help each other out as efficiently as possible. That's achieved by being in the same room together. So that's why we do not have any remote members. But the team are managed on the lower scale. You have the small groups, for instance, inner structure, outer structure, and recovery, 4 members per system there, and you have a system leader there that makes sure all the tasks of these subsystems are fulfilled. Then you have the guy on top of that again. It's the mechanical lead, and the same goes for the avionics group. They are divided in a similar manner. So Thea just briefly talked about it, but we have a set of group leaders and we have a set of technical members, but they are in a sense, or they are equal members, but they have some different tasks that they have to confine to. But we strive to have as flat organization structure as possible. A technical member can come to the board and share their opinion and have it just as much of a say in a matter than anyone else, or they at least have the opportunity to argument for their viewpoint before a decision is made. But that's mainly how we manage our team. And in the very top, we have the project manager, Thea here, which is supposed to have the entire overview. And then we have the business and marketing team handling the industry partners and sponsors and so on. So yeah, there are several ways of keeping the team organized, and by means of having designated members working on those tasks.
Is critical thinking important in your team?
Yes, I guess that is the short answer. Critical thinking, if you don't have that, I don't think you won't manage to, or if you don't start developing that when you come to Propulse, you will have a problem eventually. But it is important due to many reasons. One of them is that if it was only all the members didn't have that critical thinking and just listen to what we in the board said and what the leader said and what the mentor said, we would never develop much. They would just hear what, we'll take for example, Stetind, the project with Stetind. It was quite successful, but after that launch, we gather up and started to ask, okay, what could we've done better? What did work? And started to make a plan for how should we improve this. And you have always to have this critical thinking in order to improve and not just stay at the same level. And that is important in a student organization that is on voluntarily based, because we are responsible for our own development. There isn't a lecturer or a teacher that says, do this and this. So yeah, that's important.
Do you learn entrepreneurship, and are you considering to launch a startup?
When it comes to entrepreneurship, I would say that's more or less what we do. We are an independent organization with a budget, with bylaws and everything. So the way we are entirely run by students, so we do get the possibility to be entrepreneurs, and we get the experience of managing an organization straight up. That's what we do. And when it comes to considering to launch a startup, that's kind of a dilemma that we might be meeting somewhere down the line, because if the products that we make are very good and we see that they have large potential and there are many different the industry is ready for this product to be commercialized, that could be a big factor for us. We want to be a part of this and so on, but then again, we want students to learn. When you start a startup, it's not, the stakes are a bit higher, the barrier to entry is a lot higher, and you as a student aren't longer able to learn rocketry the same way, because well, it's now a company. It's not a voluntary student organization. So for me, if Propulse went commercial in 2018, for instance, there wouldn't have been an organization ready for me to join, and I wouldn't have gained any experience in the same manner, at least. So that's kind of the dilemma that we are facing. What do we want to chase? Do we want to make a good student environment in Trondheim, basically producing good rocket engineers, or do we want to make a good product for a specific task for a specific company or companies? Both are cool, but I'm kind of leaning more towards one of the alternatives, and you might be able to guess which one of them.
But it could also be mentioned that some of the members from Propulse in 2018, 2019, or some there have now a startup which is called Solstorm. So I guess you can say there are startups that develops from Propulse, either the members being inspired to start a startup, or that you have some. You could have an R&D here in Propulse that maybe goes to being a startup, and that is by all means a good thing.
Where do you test and launch your rockets?
Yeah, the thing here in Norway, as per now, is we don't have the opportunity to test take Stetind. We couldn't test Stetind, the whole rocket here in Norway. You can't launch it anywhere as of now. But we do have for the hybrid group, we have a test site that is under construction right now, where we want to test our hybrid engine and see how it performs. And also, there is a place in Norway called Andøya, where they now, maybe I hope, there's a lot of people that's heard about it. It will be a spaceport there in not long time, where you can launch then the orbital launches. And then maybe in the future, we are able to have a launch of our rockets there. That would be amazing.
What are the challenges to reach 9 kilometers?
There are several, but one main thing I would say that divides or makes 9 kilometers different from reaching 3 kilometers is your margins. For our case, we have, or for Birkeland and Stetind, we have a Cesaroni Pro 98 solid rocket motor with a given amount of impulse, and we want to reach a quite specific altitude. So you have to be able to utilize your motor as well as possible. You need to be quite aerodynamic, and you have to be lightweight, and you have to be stable. If you're going a bit offset and you don't have any active control surfaces, you won't hit the predicted apogee. So for our case, it's quite important with the aerodynamics. We have quite a slim and tall rocket, both Birkeland for this year and Stetind last year, which made for some challenges for the inner structure team, being able to fit all the components and mechanisms inside 13 or below 13 centimeters diameter. So that's one thing. And also the weight requirements. Our motor can't push 90 kilograms up to 9 kilometers. Stetind was about 33 kilograms, and half of that is just the propellant. So everything else, avionics, recovery, payload, needs to be within our weight budget, of course. So that's, yeah, and the fact that we go from 0 kilometers per hour to Mach 1.7 in 6 seconds also makes for some challenges with regards to the strength. It's like 15 Gs of acceleration, but it's possible to design for that. We have software like finite element method analysis and other things, physical testing that allows us to validate our design before it has to endure those aspects of flight. But I would say aerodynamics and stability are some key parameters to at least hit your expected apogee. Then you have to fine-tune the apogee with the weight, total weight. For a solid rocket motor, of course. If you have a hybrid or a liquid where you can regulate the thrust, it's a bit different story, but that's at least the main challenges for a COTS rocket as we have this year.
Do you make your own solid rocket engines, and will you do hybrid rocket engines?
We buy our solid rocket motors. We have done that for the past years, but we have our separate or parallel research and development project developing a hybrid engine. So in that sense, we are both doing making the fuel and the engine ourselves. So the oxidizer is for the hybrid engine is nitrous oxide, and then the solid part of the fuel, or the solid part is paraffin, or I guess solid kerosene, if that's the English equivalent, with some cool additives to make it perform as we want to. So yes, we are making a hybrid engine that you will probably see quite soon. Not for the rocket vehicle line flying in as a cup this year, but if you are planning to attend EuroC next year, you might see a 5-6 meter tall hybrid rocket on the launch rail.
So you use like paraffin for the solid fuel?
Yeah, correct. We use paraffin with some additives, and we cast it. We make the blend ourselves, and we cast it ourselves, so it's completely done in-house.
Are you working on a liquid fueled rocket engine?
Yeah, or not yet, as we do right now. The liquid rocket engine is, as I mentioned earlier, that is something we plan and will happen if we are supposed to reach the Karmøy line. But as of now, we focus on our hybrid engine and developing that. But after finishing that, developing the hybrid engine and launched it, we will start looking at the liquid rocket, and maybe that will turn out to be an R&D already for next year or the year after that. That might be possible.
Do you have any plans to do thrust vectoring, like vectoring of the nozzle or the vectoring of the fins?
Yeah, we do not plan to incorporate that into our design in any way, really, as long as we are competing. And there are several reasons for that. One of the reasons is the rules and requirements from the competitions. They are limiting our ability to change the attitude of the rocket, because if that mode of modulation of your position fails, you might have a horizontal rocket, also called a missile, I believe. So that's not something we are looking into, and also we have some good experience by making precise fins and good aerodynamics to the extent that you are well enough with passive control surfaces and no thrust vectoring. But of course, for later projects where we are no longer bound to the limitations of the competition or the requirements from the competitions, it would be natural to implement some active modes of attitude control to be able to reach the apogee with a given flight trajectory and so on. And we have looked into RCS for roll control, but if you have seen the launch of Stetind from on board, roll wasn't really an issue. So instead of making a complex system for roll control, we are going the more passive, I guess, primitive route, but simpler route of making good fins and good aerostructures for our rocket.
How do you design the rocket, and how do you plan to design your engines in future?
Yeah. Well, for the design of the rocket and also for the engines, we use several programs. One of them is the 3D Experience. That is a CAD program. CAD, which we use for the a lot in the concept period, but also throughout the design period. We also have the CFD for the computational fluid dynamics for the aerodynamic perspective. See, where does the turbulence come? Is there something wrong with the fins? Or and then maybe change the design. We also have OpenRocket, which I guess is known to very many people, an open source program. Also Aero. We've used all of those three for the last years, but we hope that in the future we can also use our own program, Penumbra, more. And for the engine, as of now, there's been a lot of literature. We have, or the Hyper Group has read upon, and is taking, basing on that, and then develop the concept and the design, and we'll soon start testing and see how the engine performs, and then do adjustments thereafter. I guess we'll also have to see if, when it comes to a liquid, if that is the same procedure, we will do it.
Do you use trapezoidal fins, and if you do, what advantages do they have?
Yeah, we use trapezoidal fins, and there are many reasons for that. First of all, the most important, in the trapezoid fins, you have a larger base, and a larger base than the tip cord of the trapezoid fins, and that makes it quite robust, both when it comes to during the flight, when there's a lot of load during max Q, for example, but also when it lands. It is more robust against damage in both those cases. And also, trapezoid fin is more aerodynamical in terms of turbulence. The stream of air comes more in a more aerodynamic way over the trapezoid fin, and you get the turbulence more behind of the rocket, and that is preferable. So trapezoid fins, we use that for both Stetind, and we'll use it for Birkeland as well.
Yeah, and the fins that are that we used that we will use for both projects, they are optimized for supersonic flight. So they have some sharp, both leading and trailing edges, or the wedge angle, as we call it. So they are optimized for supersonic flight, as I mentioned, because both Stetind and Birkeland will go quite a bit past the speed of sound, and the fins have to make up for that.
What sensors do you use, and do you use like PCBs?
Yeah, so we have several sensors on board. We have barometers, we have accelerometers, we have cameras, we have thermometers, a lot of different stuff. We also have both bought and in-house produced PCBs, or flight computers, and other PCBs. And that's for redundancy purposes. You would want both a commercial component and your in-house designed and produced components. And number one, that's a requirement from the competition, but also it's a requirement for a reason. It's good to have redundancy in such a tight margin of an activity as launching a rocket is. So we do that. That's kind of what the avionics team is working on, the avionics, naturally, of the rockets. So we have quite a few PCBs on board. Yeah, a lot of different stuff. If you go into our social media, you can get a good overview of some of those things if you are very interested in that.
Do you use any surfaces to control how much drag the rocket does, like air brakes?
Yeah, well, air brakes was used in 2019 when we participated at the Spaceport America Cup in 2019. We were considering using the air brakes for this year as well. There were several reasons for why we didn't choose it, but I guess one of the main reasons was that what we saw from Stetind that it was overshooting, and that's why we were considering having air brakes. But then we also wanted to improve our height estimations and then our height predictions. I guess you can see here the air brakes that was used in 2019. So yeah, they have been made. Yeah, so we want to improve our altitude predictions and then adjust for the weight instead of using air brakes for this year. But air brakes has been considered and will probably also be considered or well, in the future, it might not be that interesting when we are talking about reaching the Kármán line. Then I don't think you want to start stopping your own rocket. Then you just want to reach as high as possible. So yeah, have you been looking into that, Victoria? Have you some interest in air brake system?
Well, I find they can be interesting since they are more efficient. Like going up, almost nobody uses air brakes for going up, except in these competitions where you need to go precisely at 3 kilometers, for example. But if you want to go very high up, when you land, that's they're useful because you can use the air brakes to slow down, so that you decrease the probability of your parachute ripping.
Yeah, that's also a good point. That you can also use it when entering the hybrid or liquid engine projects here.
Do you play with Kerbal Space Program?
Yes.
I haven't done that much before I started at Propulse. Then I was introduced to it, and it's a bit of shame that I wasn't aware that was a thing before I came to Propulse. But we have had some game nights with the Kerbal Space Program here in Propulse, and we also had a competition during the recruitment period where we asked if people wanted to join the competition, and the winner who performed the best in flight performance, they were given some merch.
Yeah, and those who those who were bad in Kerbal Space Program were prohibited for joining Propulse. So that's an easy way to get good numbers. Hand them a computer with Kerbal Space Program and see if they are able to reach orbit on the first try. But on a serious note, Kerbal Space Program is it's a very good way of getting like an intuitive feeling for what rocketry is all about. Orbital mechanics, I can't imagine learning orbital mechanics any other way than watching and playing Kerbal Space Program, because it's done in a cartoonish but still quite realistic way. And also there are some terms and principles that you're introduced to when playing that you will hear again and have something to do with again when joining a student rocketry organization. For instance, apogee, I learned that from Kerbal Space Program, and we use it almost every day while talking about our rockets, for instance. So among many other things, Kerbal Space Program is a very good and fun, that's worth mentioning, a fun tool of learning about rocketry.
Do you play Kerbal Space Program?
Yes, I play a Kerbal Space Program. I should say that if somebody is able to launch a rocket which goes like to Duna on the Kerbal Space Program, that doesn't mean they've got a really good understanding of rocketry. Because there are these things called crack and dries, which are practically some bugs which let you kind of magically go up. So,
Fair point. Yeah.
so make sure nobody's using them
Yeah.
when you do
Yeah.
competitions.
And no mods allowed
Yeah.
unless it's the realism overhaul mod.
Yeah.
For Penumbra, yourself developed the rocket simulator. Why are you developing your own simulator and not using someone else's simulator? And like, could someone else use it?
There are several reasons for why we want to develop Penumbra. One of them is for, well, say learning purposes. When you develop your own rocket simulator, you learn a lot of the aerodynamics behind it. You understand how the simulator is built up and what its limits are. That is not always easy for example, Aero or other programs which is not open source. But also another important reasons in contrast with OpenRocket, for example, we want to make a rocket simulator where it's quite similar with OpenRocket, but then we want to add some data from the CFD, from computational fluid dynamics, and then to improve the simulator and the output values from it. And also have a good GUI, well, which stands for
Graphical user interface.
That's right. That was the word. And then when we develop ourselves, we can tricks with it the way we want to do. So yeah.
And another thing, OpenRocket is kind of like sketch based with 2D plots, but Penumbra, it's going to be a fun user experience with like a 3D representation of the rocket and its environment throughout its flight. It's not a 2D plot, you can get that as well, but you actually follow the rocket all the way up and through parachute deployment and all that, as you would in, for instance, Kerbal Space Program. So it's going to be, for us at least internally, it's going to be a software that we know how to use from back end, front end, everything, and it's also a pleasure to use. And those things put together is quite a good combination. And and when it becomes as good as we want it to be, making it open source and sharing it with the world would be something we would want, because why restrict anybody else from using our tool if it ends up, or if it results in them making better rockets? We would want.
You could do like that. You can import a 3D model. So like if somebody designs something like in Fusion 360, they can import it there.
Yeah,
so it'll be easier.
That's what we are doing. So for our rocket, we export a step file of the assembly, and they run a simulation on it. And you can see your rocket with your fins and your nose cone and your length and all that go up into the sky.
Because well, for the as you mentioned in OpenRocket, you only have, like, you can choose a tube, you can choose those sort of fins, but having the details, like for example an angle, the wedge angle on the fins is not that easy to have in OpenRocket. That will be possible for the Penumbra simulator.
You have a payload with the ferrofluid. Did you choose ferrofluid for your payload?
So the payload experiment was based around utilizing the quite dynamic G, or acceleration environment that our rockets endure. So at some points of the flight, you can have 15 Gs of acceleration, and at different or another point of the flight, for instance at apogee, you have effectively 0 Gs, or you have some sort of weightlessness. So we wanted to see how the field lines of a quite strong magnet affected, or how the ferrofluid would confine to those field lines at those different G loadings. So we had a camera looking at our ferrofluid experiment, and we were quite excited to see how this would turn out. We had some expectations, of course, but it turned out that due to some stuff happening at the launch rail and so on at the competition EuroC, the payload's battery were dead when we launched. But the magnet was still on, so the ferrofluid had the time of its life, but no one was there to observe it. And it's also worth mentioning that the payload, which flew in Stetind with the ferrofluid experiment, was made by Orbit NTNU, not Propulse. So that was Orbit is another technical organization here at NTNU, and they are building satellites. They're actually launching aboard Falcon 9 this summer from Cape Canaveral. Their selfie-sat, it's quite a funny concept they have there. So you can search for Orbit NTNU if you want to know more about that. And also the first orbital flight from European soil, mainland Europe, is from Norway. And their other satellite will be a part of that launch. So that's ISAR Aerospace, German aerospace company, which are launching their rocket there, scheduled for late 2022 from Andøya, which you mentioned previously, one of our partners.
About competitions, why are they important for you?
First of all, competitions, they force us to have it's an important deadline. You have to work towards the competition, and when you have, that is a pretty set date, so you can't just push it whenever you want. And that is motivating, and it makes it possible for us to make a rocket within a year. I don't think without the competition, I don't think we would be able, but we wouldn't have done it because we don't have that timeline. And also competition. At the competition, you have this networking arena, the opportunity to meet other teams, to see the rockets. We at EuroC, we were able to see 18 other rockets, meet the team, speak to them, how they do things, meet the judges, and also some of the industry there. So and also for us, that as per now, that is not able to launch here in Norway for such a big rocket. That is our way to the Stetind Birkeland launch, which is the best feeling ever. So that is why we're competing at competitions such as EuroC and SAK.
Yeah, and it's also a good way to see if your design actually is good or not. One thing is if it flies and if it lands, but another thing is how it competes against the other teams on like the design choices, the validation and the technical report that you also write for your project. It's a good way to see if we really are any good, and it's motivational if for all members to see how a project from Propulse does it in a competition. So it's a good way to motivate the team and to get good feedback on your projects.
What did you learn in the EuroC 2021?
Yeah, what did we learn? You learn a lot about what should you continue doing and what should you not continue doing. And also being at EuroC, well, there are two things. The one is we have been working our ass off for over a year. It wasn't like we weren't. Yeah, we were working for making this happen and try to prepare ourselves in the best way. But at the competition, there was a lot to do, and there were some of the preparations that hadn't been fulfilled all the way through before we traveled to Portugal. Some due to just lack of time. So being prepared is very important, and we were working towards that. But with that experience, we also know what we should focus on prioritizing in their preparation, like such as the checklist, the assembly, and what to not do. But with that said, because of the great team, we were able to launch. So if this is to happen again at EttoCraft, we know that even though there are some things that needs to be done when we're at the competition, it is possible to pull through if we just decide to work together on this and reach that deadline, which we were able to do. So you also learn how important it is with the team spirit. There were, I think we were, not to be biased, but one of the great teams to have a good team spirit. We were backing each other up, and if there were someone who needed something, there was always two people around and just running and getting it. And yeah, stressful, but a very fun experience and valuable.
And I would, from a mechanical design point of view, I would say that the main outtakes from the competition is how important ease of assembly is. Yeah, your design is quite good and it will probably do very good during launch, but if you aren't able to assemble it before your flight window, it's a bad design, at least in these cases where you have such time constraints. So ease of assembly is very, very important. And it will, if you have a hard rocket to assemble, your time at the competition will be just as hard. You will be working your ass off all day, every day until launch. But if the rocket actually was easy to assemble, you could perhaps have somewhat of a vacation while you're on a competition. And that's kind of an overstatement, perhaps, but you get what I'm trying to say. And also, it's a good reference point to what are the really important things about the mechanical design and what are the more not as critical things. So you get kind of a critical path towards flight for your project, which you wouldn't have had if you didn't compete, because then all concerns, all uncertainties would kind of be at an equal stance, and you will have everything going around in your head at the same time. When you get the reference points on what's important and not, you're able to get the important points and focus on that and make sure that the critical parts are working.
And also a really important thing to remember also when we are to participate at EttoCraft this year and then EuroC next year, be prepared that there is a lot of things that won't go as planned. For us, nothing went as planned. There was our third attempt at launching. That was when we were able to have a successful launch. Before that, there was a misfire, and there was what we, at least me, I thought for a couple of minutes there that we wouldn't be able to have the launch because of that misfire. But the team just wrapped their head around it and started running everywhere and just speaking with the judges. When do we have the next time slot? What should we do to improve this? And that will, at EttoCraft, there will be things that we're not prepared for, at least in the beginning, but then we just have to be solution oriented. And that is important.
And when you're on the topic, things not going to plan, would you mind, Thea, showing the audience what you have hanging on our wall there?
I guess we can try it
closer.
Here you have the Stetind rocket, and as you can see there at the aft airframe, there was some weird things going on. Do you want to?
Yeah, so
explain?
This goes out to all teams. It goes out to you also for your future projects. Remember to use Loctite on essential eye bolts because if they are able to loosen, your rocket will fall down to the ground without the parachute that just deployed. So simple solution to quite an expensive problem, one could say. But we recovered the aft in a presentable shape, even though it fell 9,000 meters without the parachute down to ground, because the little tube of Loctite that we had on our table in front of us, we did not apply that on that specific eye bolt. So yeah, those are the small things. We would never have thought about that if we weren't to experience it. And it's worth mentioning that yes, we thought about applying the Loctite, but there were another issue that made us not go for that alternative. But that alternative that made us not go for it obviously wasn't as important as the fact that we could have lost the entire aft airframe. So you have to weigh your or the outcomes. What is more expensive to lose, or what is has a more affectionate value for you to not lose. And yeah, so many good reference points to what's important in rocketry by being a part of a competition like this. And also we won our class even with this stuff happening. So if you're able to apply that Loctite for SA Cup this year, we might score a few more points on the recovery part.
Do you have any useful exchanges
with the other teams there?
Yes.
Yeah, we met a lot of teams, and they're like at paddock. You just have a bunch of tables in line, and with the rockets and with the teams behind it, so you can go around and speak with them and ask questions about the rocket and point there and there. So there was a lot of useful exchanges with the teams, and also the fun thing, we were staying at something called orbital camping, and there were also other teams from EuroC living there. So yeah, we had some social nights there, and also spoke about the launches, and some maybe launched the first day, other did the third day, and just asked for tip. And so yeah, many useful exchanges, and we look forward to see many of them at SA Cup again.
Did you have more rockets at EuroC?
No, Stetind was the only one. And we had more than enough to do with that one rocket. Yeah, so that's pretty much the way we do things in Propulse. We have one main project going on at any point in time, so no parallel flight-worthy projects, one could say. But yeah, Stetind flew at EuroC. We flew on 15th of October 2021. Yes, I remember the day because it was one of the best days of my entire life. You could just imagine when you've been working on a project for quite intensively for 14 months, and you're standing there and you're hearing the countdown, 10, 9, 8, 7, and I remember thinking to myself, in 10 seconds, I know what happened to Stetind. I would know if it flew straight up, I would know if it crashed, I would know if it exploded. It was a quite weird feeling that knowing, okay, I have 14 months behind me, and I have 5 seconds in front of me. And then there's this quite significant change in the project's life cycle, one could say. So I don't know if you've seen the promo videos on our YouTube channel, but I had a GoPro on my head while watching the launch. And the people that work with me and know me haven't heard that side of me until then. I could say that for sure because I used my voice thoroughly while watching that launch, and I didn't. It came natural. There it was, Stetind. It's flying in front of my eyes. It's going quite well at the same time. So I had no other choice than to just release all the built-up energy, stress. Everything came out in a happy roar, or several happy roars.
And also remember, this was our third. Like we had seen the first time we saw, and they were like 3, 2, 1, nothing happened. And then we just hear on the speaker, misfire. And we're like, oh, no. And then the second time it was like, okay, it's good. And 3, 2, 1, and nothing happens. And then the team many of the teams was probably think that, okay, this is over. And then 2 hours, 3 hours after, they go again, like 3, 2, 1. And then it takes 1 second before something happens. So in that 1 second, I thought, no, it didn't work again. But then you start hearing the and you start seeing the smoke, and that's when the roaring happens. So that is worth the 14 months, or for us it's 2 years almost now. So yeah.
And for those curious to the actual details on what happened, we had a igniter which followed our motor from Cesaroni. On the first try, there were an electrical failure on the wiring between the power supply unit and the igniter itself. But they were able to change that or fix that within the launch window. We had a 15-minute launch window when the airspace into Lisbon had to be closed because we were going up to cruising altitudes for airliners. The second time around, the igniter ignited, but the fuel did not. It was too weak. Who would have thought that the igniter that we got from the producer to ignite their fuel did not work? We could never have expected that. So we got a new flight window, launch window, and we got a new igniter. The pyro guys at EuroC made entirely homemade, do-it-yourself igniter, an igniter on a stick. So it was a beefy igniter because this time it had to work, and it worked. So yeah, prepare for the unpreparable.
Yeah. Do that.
Or just to be handy when shit goes down.
What about the other teams that won some prize?
Yeah. Well, as I mentioned, there were several of them living next to us at the camping. For example, Skyward that won the Solid 3 Kilometers Flight Award and Team Award. Those were funny people. And well, the thing was, they did it pretty good, or they did it really good, and they did it at the first or second launch day, I think. So they were having pretty relaxed days after that while we were running all around, but really nice people. And also for the other teams, no, it was great hearing what their thoughts behind the rocket and seeing they do it such being so successful, and also with Danstar with the liquid 9 kilometers flight award. It's pretty fun because if you look at the world map, you see that you have Norway, then you have Sweden, then you have Denmark, so the northern countries. So it was cool that both we, Norway, and Denmark were flight award winners. So that was cool.
What do you plan to do in 2022?
For Team 2022, for the team that is now, we will participate at Spaceport America Cup 2022 with Birkeland. And then after the summer, we will start up with the new team 2023. And it hasn't been set in stone yet how that project will look like. What kind of R&D will we have? How large team will it be? And if it will be hybrid or how it will be. But I can say there are a lot of people who want to have a hybrid launch at EuroC in 2023. So yeah, that might be the case. But as of now, we focus on the SA Cup 2022.
Yeah, and Birkeland is a quite similar rocket to Stetind. It will go to 30,000 feet, solid rocket motor. For the new team that we are going to start up after the summer, everyone is able to join as long as they are a part of NTNU in some sort. So if you are an exchange student thinking about coming to Norway, I would suggest that you come to Trondheim, NTNU, and I suggest that you would apply for a position in Propulse in August and September when the semester starts.
What advice would you give to young rocketeers?
Be curious. There are a lot of information out there, and there are a lot of experience to be gained by doing stuff yourself. So just be curious. Try doing something at every point in time. If you are researching something or just watching videos, awesome videos on the topic, follow along the news, the new technology that is being developed, and try your own ideas. For me, one of the greatest things that I've gained from being in Propulse is the experience of doing something that is my own. So try to be curious on what's going on out there and applying that in your own projects. So yeah, and I would also advise anyone out there to try to join a team. There are a lot of tasks to be done to make a cool rocket fly. You don't have to do it all by yourself. So try to find a team with cool people, because cool people and excited people can do a lot of great things. And if there aren't any teams around, why not be the person starting up the team? Propulse was founded by some people who wanted a rocket team to be a part of their life. So they just founded it, and now we're here with 60, 70 members. Yeah, so I guess that would be my advice.
Yeah, I just totally agree, and I think that what we're doing is a good example because we have joined a volunteer-based student organization making rockets. There are some out there in the community, and also what you do is a perfect example of what you should do. You should just start engaging, and you were the one that emailed us, and we think it's super cool. So just start networking, finding people who think space is cool, think the same as you, and start even have if it's an organization, startup, or just a few meetings or workshops. That it doesn't matter. Just start doing something if you think it's fun.
Yeah, I think you're starting to get quite a invaluable basis for starting a Rocketry team, because you have now interviewed quite a few of them and gotten to hear all their secrets and experiences. So you might know what to avoid now with regards to eye bolts and Loctite and so on. So that won't be a part of your first launch, I hope. Yeah, so it's fun to see that people are as engaged into this as we are ourselves, and the fact that you are so young and already as interested as I am right now. Well, and I'm working on it. I'm quite happy to see that. So keep on with the good work.
What do you think is the best place to study rocketry?
If you come to Norway, I would, or there are actually several universities you could go to study. We don't have any rocketry department at any of the, or not at the university here in Trondheim at NTNU, but there's been there's come several astro and space technologies subjects here at NTNU, and also you have us, you have Orbit NTNU, you also have other technical organizations making other cool stuff. You also have Ascend that make drones that could be related also to some sort of space. So yeah, I would say Norway, especially the coming years with Andøya and the spaceport there, will be an interesting place to study rocketry. As young, I thought that I had to go to United States or maybe Switzerland for studying astrophysics, rocketry, space technology. But now I actually think that Norway is a good place to do this when there exist organizations like this. Yeah.
What are your favorite space movies?
Any guesses at all?
I don't know. The Martian?
Well, that's a safe option. The Martian is quite. It's a brilliant movie, but the one that caught my eye the most is Interstellar. Um, it's not. They're on the limits of what's realistic and in accordance with theory and all that. But it's quite a great movie in my opinion. Inspiring movie. Lots of great visuals. So your imagination is able to run a bit wild, thinking about, oh, this is how it could look. So Interstellar is a good one for me, and I like also, it's more of a documentary, but the movie about Apollo 11 launch. It's on YouTube. You have to pay for it, but still it's on YouTube if you want to see it. It's quite good. It's very cool footage, and for me at least never before seen footage from the Apollo 11 launch. But what about you? What's your favorite space movie?
I also like Interstellar. And The Martian is also a nice movie. Yeah, I think those two are good movies.
Yeah.
Well, I agree also on The Martian. I thought that was since when I was 12 years old and up till 18 maybe, I was quite determined that I would be the first one reaching Mars. And that was a movie that fitted right into that dream, although it was a bit sketchy that they just left him though. But a good movie. And also I like to see some documentaries such as Cosmos with Neil deGrasse Tyson, and yeah, there are several good out there.
Do you have any questions for me?
Yeah. Well, like we've been saying a bit that it's quite impressive what you do. And it was very funny that you just emailed us and like, okay, guys, do you want to have an interview with me? And that is, I have never met someone that young and would just, do you want to join an interview about rocketry? And knowing so much that you do in the age of 11, 12? Is that
10.
10. Oh, all right. Okay. Yeah. So, why are you so fascinated about space? What have inspired you?
So I'm interested in space from a long time. So I don't really remember where my passion started. But now I like it. I think it is useful to know. So rocketry kind of includes all of science in it. It's a very big thing. So learning rocketry kind of means learning a bit of everything.
Hmm.
Except maybe, I don't know, language, maybe.
Oh, it might. And you are at the school founded by Elon Musk, but but you also attend at normal school, or is
Yes, because there's this weird thing here. So if you go normally at school like a normal kid, practically you don't do anything. It's way too easy. But if you decide you want to do some homeschooling, then you have to do an exam at the end, and it's definitely harder than what you're doing at normal school.
yeah. Hmm. And at the normal school, are there anyone equally interested in space as you are? Like, have you found some friends that you can bond with about space?
No, I haven't. My class is kind of small, so maybe that's a reason. We're only 14.
Oh, okay.
So then probability just says kind of, no, you want to meet someone.
No. Well, but then it's a great solution, the thing you're doing, just reaching out to the one you know is interested. You also inspire us when seeing like you can be 10 years old and doing all of those things, then there is no limit. So that's no really cool. Mm.
Yes, probably the problem I'm having now is that I really can't do everything I by myself.
No.
But there's kind of nobody here which is interested.
No, like I guess you have interviewed Skyward, right, from Italy.
Yes.
Yeah.
Well, I haven't really interviewed. I talked with them. I did not interview them.
No. Okay.
I will interview them. I haven't yet, but I will. I made a talk to them. There's no video about it. But
No. But so I guess you like if you don't find anyone for now that is on the same age as you that is equally interested, I guess you can also start speaking with the Skyward or the Italy teams. But also, as you said, just start your own thing and let it out on social media and make sure that the people know. And also say it to your class. Maybe there is some there that actually thinks it's a bit cool, but maybe doesn't say it out loud as you do. So yeah, keep on doing what you're doing.
yeah, I have like a small team. The problem is that I am here in Italy, then there's someone in one part of America, another person in another part of America, and there's someone which maybe is in Great Britain.
Okay.
Anyways, we are just splattered around the world.
Yeah.
Which means also building stuff together is difficult.
Yeah.
Yeah. That I get, but yeah, it's a starting point, and it's pretty fun that you also have United States, you have Italy, and you have Great Britain. Maybe you'll find one more here in Norway, so you just have it all over.
Is there any other passions you have except from like space and technology, or any other hobbies, or is this kind of taking up all your time?
So attending two schools, that means that there's lots of work to do. But like the free time, I kind of only have this. It's something big, let's say. It takes a lot of time to do some progress. Like I did a couple of years ago, sugar rockets. They fly well, but I decided that I can get maybe to 2 kilometers with them, but no more. And just even for the future, I need the liquid fueled rocket engines, so I'm building some now.
Right, you just step right into the liquid. That's cool. Just don't forget about safety rules and all of that, though.
We see you do on your YouTube channel the do-it-yourself stuff. That's pretty much, or that is your that's obviously your hobby. That's what you are referring to, right? Yeah.
There's some older videos. There's some older Minecraft videos, because I started a long time ago this channel, and my interests changed sort of for the videos, because it's harder to find an audience for Rocketry than for Minecraft. Like there's maybe like a billion. I know that all Minecraft videos together have more than 1 trillion views. It is a lot. Rockets, no. Like this Skyward, which has like 100 members, and the YouTube channel has only about 300 subscribers, if I remember correctly.
It's weird. It's really weird that there are so many people interested. Like, okay, sure, Minecraft is fun, but Rocketry is much more fun than Minecraft, and much more interesting hearing and seeing. So I guess we have to do something with that.
Yeah, it's all in the way it's presented. The rocket channels that are doing great, they are doing it in a very good way. Easy to digest. Everyday astronaut. He's a good example, and his his motto is to bring Earth down, or bring space down to Earth for everyday people, because the audience within space and rocketry hasn't necessarily been ordinary people or the masses. So it's such an exciting field with a lot of awesome things to see and hear and feel, but you have to be aware of it. So for our case, we are not really using our YouTube channel to reach out to everyday audiences. It's just a place where we upload some of the promo content that we would place on other channels or medias anyways. But I think there's a big potential for like a good space YouTuber in Europe for European audience with European competitions, and you could, for instance, go around at EuroC interviewing the different teams, visit the launch rail if you're allowed to do that, make YouTube videos of that, because the teams themselves aren't necessarily prioritizing that when they're down there. So that's that would be cool if someone did that.
Yeah.
But who will that someone be?
I know that people think it's like impossible, and I kind of understand why they would think that. I mean, like, I don't know, NASA took billions of dollars to reach to the moon, and 50 years have passed, and there was practically no American astronaut launched on the American rocket. And also there's the thing that the moon is big, so when you look at it in the sky, it looks close, but it's very far away. So people think, oh, it's close. Why did we take billions of dollars to reach it?
Yeah, a good reference point there would be to figure out the value of our rockets and see how much it costs for us to take them up to only 30,000 feet or 9-10 kilometers. It's a lot of money, at least if you're a student. You wouldn't otherwise have gotten access to that amount of valuable stuff. So for us, we're in it. We are able to understand it, but of course, and the thing I hate hearing is why spend money up there when there's problems down here. And those thoughts and problems arises when the general masses are not aware of the opportunities that space brings and have already brought down to Earth. That again ties into the importance of people being able to bring space down to everyday people. Because if everyday people are on board with what happens in space, yeah, then we'll become a spacefaring civilization. If the people are not on board, that would be just a handful of rich people, because that would otherwise be the only way of achieving it.
Maybe to reach this goal, there should be like some rocketry clubs, like in bigger cities.
Yeah, as in to gather or to gain supporters that watches the launches, like a soccer team, for instance, to bring the excitement of soccer as the local teams do to their local communities. A rocket team would be able to do the same. That's what I understood from you, and
Yes.
I would totally agree. The people who actually were able to attend the launch of Stetind are the people who are also the most excited of our followers, because they know exactly what it is we are doing. They are not just seeing a couple of posts on Instagram and hearing a handful of stories from the people they know that work here. It's when you actually see what we are doing, that's the exciting thing. So yeah, but then again, it comes down to the safety and how close can a lot of people be to a launch to still consider it safe and as enjoyable as it would have been if you were only 600 meters away. But yeah, that would be a future that I would like, if the hooligans are hooligans for space launches instead of a white orb going along some grass fields. I would say that's a good way to spend it. That would be a win-win: excitement and progress, instead of only one of those two.
I guess that should also be one of our long-term goals, is just having the huge rocketry clubs. And like this is one of our goals right now, is to show students in particular how exciting and interesting and fascinating space is, and how close it is that you can build rockets as a student. You don't have to wait till you're 30 or 40 years. It is possible to do right now, and I think that will help people, showing that you can start with it, and even at the age of 10, it appears you can start in molding. So yeah, it is possible.
Yeah.
But it would be cool to have another chat with you, maybe in a couple of, maybe after the competition, even just we can talk about that and hear how you're going with the team you want to start up, and yeah, and also important that if you ever travel to Norway with your family or just by yourself at a vacation, you have to drop by the office here in Trondheim. So come here at a visit sometime.
Thank you for being here in this interview and for supporting the passion for rocketry.
Thank you.
Yeah, thank you.
Thank you.
Really fun. All right, see ya.